Chapter 5.5 Functions. Okay, in this section we will learn the definition of functions. Okay, first of all, the function. Okay, function, what is function? Okay, function is a relation between input and output. Okay, input and output. So sometimes what is the input? Yeah, input, right? Input, just give an input. Then using that input value, it calculate something and they will give you an output. So set of input. Okay, the set of all inputs, we call it domain. Domain, set of all inputs, and then set of all the outputs is called the range. Range. So the relation between 2 points, between input and output. So why don't I write something like this? Here is the input values, like a 1, 2, 3. And then this is input values. Let's use capital letter X. So X is a set of all input values. Let's say the input values are 1 to 3. And then here is the set of outputs. Let's say uppercase Y. And then this one, let's say, okay, 1, 2, 3, something like, some information, some values 1 to 3. So this is a relation. So there is a relation from input, then you get the output. So the relation. So let's say the relation is a function, right? Function. So why don't we use a small letter, lowercase f. The f is the name of the function. So this is a relation. So if input is 1, then this will be, the output will be 1. If input is 2, then let's say output goes to, the output will be 3. If the input is 3, then output will be 2. Okay, so for each input, there is an output. Okay, input, you have an output. Okay, so this is a function relation. This is a relation. I don't know what the relation is, but once you give an input, then you will give an output. So in this case, for each output, for each input, there is only one. There is exactly only one output. Okay, exactly only one output. So if a relation has this condition, if a relation is this, for each input there is exactly one output. Okay, then this is a function. We call it a function. So we have a domain and a range. So in this case, okay, we can write the relation in an order pair. That is, XY order pair. So set of all this order pair is what? X equals 1, when X equals 1, Y equals 1. X equals 2, Y is 2. X equals 3, Y is 3. So look at this. Is this a function? Okay, we have an input. So input comes, so X is the input. Always the first coordinate is the input. And then the Y coordinate is the output. Output that corresponds to the input value. So we have 1. Okay, by looking at this. Sorry, let me pause this. Okay, so let's say this is a set of order pairs. Then this set of order pair is a relation. Okay, relation has input and output. So in this case, the input. So input is domain. We call it domain, right? So in this case, the domain. We are just using the same example here. So domain is what? X values. Here is X, right? X. So domain is a set of all the elements of X values. So 1, 2, 3. And then range. From this range, what is the range? The range is the Y values. Right? Y values of each order pair. Right? So that is set of 1, 2, 3. Okay, so domain. Domain is the x coordinates of the order pairs. Domain is the what? Let me erase this. Okay, domain is the x coordinates. X coordinates, right? Or input. Okay, and the range is the y coordinate. Or output. Okay, so once you draw this order pair, the relation, draw the relation in a diagram like this. Here is the domain x, here is domain y, right? And this is the relation f. So 1, the input value 1 matches what? 1, right? 1. And 2 matches with, this is 3, right? 3. 2 goes 3, sorry. This should be 3, sorry. This is 3, and 3 matches to 2, right? 2. So based on this relation, instead of order pairs, we can draw a little diagram. 2 matches to 3, and 3 goes to 2, right? Okay, and then let's check. Let's check each input. So here's input 1. This one has only one output, 1, right? And this input 2 has only one output, 3. And input 3 has only one output, 2. So for each input, there is exactly one output. So this is a function. Okay, this is a function. All right. Okay. Okay. Let me give you an example of not function. Not function. Here is x, y. Okay, 1, 2, 3. Here's 1, 2, 3 output. All right. Let's say the relation is f, and let's check whether this is a function or not. Okay, 1 goes here, 2 goes here, 3 goes here. Is this a function? Oh, this is an example of function. Yes, this is a function. This is a function. Because what? Because 1 has only one output, right? This one has only one output, which is 1. And 2 has only one output, which is also 1. And 3 has only one output, which is 1. Right? So each input, it doesn't matter whether the output, whether the output has many inputs, it doesn't matter. For each input, okay, for each input, if it has one output, then that is a function. Function. How about this? Another example. X. Here is y. 1, 2, 3. 1, 2, 3. Okay, how about this? 1 goes here, and 1 goes here. 1 goes here. Is this a function? This is not a function. Not a function. Why? Because the input 1 has 3 outputs. It has 3 outputs, right? Input 1 has 3 outputs. So that's why it's not a function. So input must have, each input must have only one output. Okay, let's try more examples. Okay, here is x, input x, output y. The relation is f, 1, 2, 3, 1, 2, 3. How about this? This one goes 1, this one goes 2, and 2 goes 3. How about this one? Is this a function? And this one goes over here. Is this a function? No, not a function. Why? Why is it? Why is not a function? Because of this input 2. So the input value 2 has how many outputs? It must have only one output, but has 2 outputs, right? 2 outputs, which is 2 and 3. So it's not a function. 2 outputs, so not a function. Okay? Can you see it? So each input must have only one output. Okay, how about this? What if I graph something like this? Here is x-axis, here is y-axis. Is this a function? Is this function? So x is an input, right? X is an input. So this is an input, right? Input. And then based on this, y is the output. Yes, this is the function y. Because for each input, let's say this is 1. This one has this point. It has only one output. Even this one, 2 has this point, and this point has output, right? Output. This one is -1. -1 has this point, and this one has one output. So each input has one output. So this is, yes, it's a function. How about this? Another example. Here is x-axis. Here is the y-axis. And then let's check this graph. Is this a function? No, this is not a function. Why? This is not a function because look at this. If x equals 1, then this one has 2 points on the graph, right? 2 points on the graph, and each point has one output. Let's say this is 1, let's say this is -1. So if x equals 1, it has 2 outputs, right? 2 outputs, 1 and -1. So it's not a function. Make sense? So one output. So in this case, here is x, here is y, and the relation is f. Then 1, 2, 3, 1, 2, okay, -1, something like that. So if x equals 1, then we have y value, which is 1. Okay, for this y value, y is -1, right? -1. See, can you see it? So input value 1 has 2 outputs. So since it has 2 outputs, it's not a function. Make sense? All right, then. Okay, x is the input and y is the output. So we can write it like this. Okay, let me draw a little box. Okay. Something like this. Okay, so input. So this input goes inside this box. Input. Let's say x value. X value goes inside. Then this one will calculate. It will do some internal work, and then it will give you an output. We will say y. Okay, y. So if 1 is given, when 1 goes inside, then it will do some calculation like this: x plus 1. Does it make sense? X plus 1, and then it will give you the output, which is 2. So we can write it like this. Y, the output is equal to x plus 1. This expression, x plus 1. So if one input is given, input goes inside. So if x, okay, let's see here, x and y. If x equals 0, then what happens? 0 goes there, then 0 plus 1 is 1. So 1 will be the output, value 1. If x equals 1, so 1 goes inside, so output is x plus 1, right? X plus 1. So 1 goes inside, and then 1 plus 1, you will do a little calculation, 1 plus 1, right? So that is equal to 2. So 2 is the output. Okay, keep going, right? Keep going. So if x equals 0, then 0 plus 1 is 1. So that is the output. If x equals 2, then 2 plus 1 equals 3. So output is 3. Make sense? So we can write it like this. This y is the input, y is the output. And then x is what? X is the input value. Input, right? So the right side, you will calculate the right side, and the result of the right side will be the output value, y. So sometimes we write it like this. Instead of using y value, we will use the notation f of x. Like this. Same thing. This means y means f of x. Okay. Y is the output. So f is the name of a function. Remember, name of the function here. The relation is f, right? F. So we will use the function name f. So f can be, you can use g, h, it doesn't matter. So f of x, g of x, or k of x, it doesn't matter. You can use, g of x, or h of x, something like that. Okay. So how do you read this? F of x. We read it as f of x. You can read it as f of x, which means x is input and f of x is output. Okay, or this is the value of y, right? The value of y, f, the value of function at x, right, x. So f of y is what? F of y, I'm so sorry, f of x. Sorry, f of x is the y value. Y value. What's y value? Y value is the output. Okay, so this is how we read it. But we usually read it as, f of x, which is the value of f at x. Okay, so if an input, let's change this one into f of 1. Then what is f of 1? This x is the input, right? X is the input. Now the input value is 1. That means we will replace x. So given input value x, then what? You will calculate some work and then you will give an output. So the right side of the equation, the function x plus 1, is the expression in the box, right box. So just replace x with the input value 1, which is 2. So f of 1 is equal to 2. Okay, what do you mean by f of 2? F of 2 means replace the input variable x with what? Replace the variable x with the input 2. So 2 plus 1 is equal to 3, and so on. So if you're given input, so why don't we give an input a? Then what happens? Then this will be a plus 1. Can you see it? Okay, so just replace x, the variable x, with the input, the given input value. That's it. That's the function. So we have only one output for each input. We cannot have more than one output for one input. Alright, so based on this, let's try some examples. Okay, so let's find the domain and the range of the relation. Okay, relation is a set of order pairs. The order pair, it has x value and y value. X is the input, y is the output. So the first coordinate is the x values, right? X values. X, this is y value. So x value is input or input, and the y values are the outputs. Right? So why don't we draw a little diagram that representing this order pair? So here is the input values, x, and the output values, y, right? So input is the domain. So domain is the input. So in this case, domain is a set of all input values, which is -5 from the first point, and from the second order pair, -3 and -1. Okay, range. What's the range? Range is the output values, set of all the output values. Okay, set. Okay, to write a set, we will use this square bracket or curly bracket. So curly bracket means a set. Okay, set. Okay, set of all the y values. So 1, 3, and 5. Okay. So that's the domain and the range. So input is the domain. So set of all the input values. Set of all input values is the domain, right? Domain. So this is the domain. And range is the set of all the output values, range. Okay. And then from this, let's find whether this is a function, the relations function. Okay, in order for this to be a function, one input, one output, right? One input, we must have one input with one output, with only one output. Okay, only one output. Okay, so let's draw a diagram so that let's check whether each input has only one output. So this is the domain x, range y. And then -5 matches to 1, -3 goes to 3, and -1 goes to 5, right? So as we can see this, the relation is function. Yes, it's a function. Yes, it is a function. Why? Because each input has one output, right? Each input has one output. So this is a function. Okay, and then let's try problem 1. Okay, problem 1 is also simple. Let's try. All right, from here, let's find the domain. So domain is the set of all the x values, right? X values and the y values. Okay, so domain is the set of all the input values. So domain is a square bracket, and then x is 1, 1, 1, 1, 1. Oh, only 1. How about range? range range is the set of all the output values, which is 0. For the second point is 1, third one is 2, 3, and 4. So we found the domain and the range, but we are not sure whether this is a function or not, right? So if you graph it, so this input value x, output value y, and then let's say the relation is function f, and if x equals 1, then y is what? Y is 0. X equals 1, 1, then y equals 1, right? Look at this. The input value 1 has how many outputs? It has more than one output, right? More than one output. So this is not a function. Not a function because of what? Because the input 1 has more than one output. Does it make sense? Does it make sense? So input must have only one output. You cannot have more than one output. So the domain is 1. Okay, each order pair has x value 1, right? 1, 1, 1, 1, 1. So if it has 1, 1, 1, 1, 1 like this, then we use only one element. Only one element. So instead of using all of this, just use 1. Okay. So input 1 has many outputs, so it's not a function. Okay. Okay, example 2. Okay, evaluate this function. Okay, f of x equals to x minus 4 at x equals 3. Okay, what do you mean by this? Evaluate means, give input values and then find the output value. So give one input value and then calculate it, find the result as a value. So f of x is a y value, output, right? Output. So here it is. F of x is equal to 2x minus 4. And then we want to when x equals 3. This means the input is 3. The input is 3. So you can replace this x with 3. So this means change the value of x, the variable x, with the input value 3. So what we do is change the right-hand side, change the x in the right-hand side with the value, input value 3. That's it. So f of 3 is equal to, this is 6 minus 4. So f of 3 is equal to 2. Okay, so that's the answer. Evaluate. So evaluate means, x is given. Okay, so plug in that x value and then calculate, find the result. So that's the output. So here we say that x is the input value, or input. And then once you calculate, and then this is the output, or output. Output y, right? Output y. Okay, that's how we evaluate a function. Okay, so we want to write the answer in order pair. Okay, on order pair, write an order pair that is an element of the function. So when x equals 3, y is 2. So always when you write an order pair, you have to write the x coordinate first, right? X value first, which is the input, right? Input, and then write down the y value, which is the output. Okay, so this is the order pair. So that's the answer. Okay, that's the answer. Okay, for next one, we will do the same thing. Okay, evaluate this function f of x is equal to negative 5x plus 1 at x equals 2. So that means the input is 2. So replace this input with 2. Then we have to rewrite this x with what? Replace this x with the input 2. And then calculate. So f of 2 is equal to negative 10 plus 1. So finally, the y value, the output when x equals 2 is negative 9. Right? So the answer in order pair is what? X equals 2, y is negative 9. So this is the result. Input is 2, output is negative 9. So always write down the input value first, x first, and then y later. Okay, I should use Therefore. Okay, this little triangle means therefore. Okay, therefore. Okay, exercise example number 3. Okay, find the range of the function. Range of the function given by the equation. So we have an equation, and this equation has a input and output. Input and output. So if the domain is given, so how many x values, input values? Domain is the input values, right? So domain is the what? Input values, right? Input values. So input values are -4, 2, 0, 2, 4, so 1, 2, 3, 4, 5. So there are 5 input values in this case. 5 input values. So based on these 5 input values, once you plug in the input values, you will get the output value, right? Output. Okay. So we want to find the range. What is the range? Range means output or output. Output. So based on the input, we'll get the output. In this case, f of x, right? F of x. The input values, which is x. So domain is the input values, x. They are what? -4, -2, 0, 2, and 4. F of x is based on each input. So let me write an f of x. So f of x is equal to -3x plus 2. So from this, there are 5 input values, so we will have 5 output values. So the first one is when x equals -4. So x is -4, -2, 0, 2, and 4. These are the input values. So based on each input value, we will find the output. So if x is -4, then let's find the output. So -3 times x is -4 plus 2. Then let me go to the right side, right? Continue. So this is 12 plus 2 is 14. So when x equals -4, y is 14, right? So write the 5 order pairs that belong to the function. 5 order pairs. 5 inputs, so we have 5 outputs. So we have 5 order pairs. So we can write it as this. Here is set of order pairs. So the first pair is what? When x equals -4, y is 14. Okay, we found one order pair. Okay, next input is what? The input value is -2, right? -2. -2. So -3 times -2 plus 2. Then this is 6 plus 2 is 8. Right? So -2, then y value is 8. So when x is -2, y value is 8. So this is the second order pair. Then let's find the third one. F of what? The third one is x equals 0. The input value is 0. So -3 times 0 plus 2. Then 0 plus 2 is equal to. So the input is 0. Then what's the output? Output is 2. Okay, so that's the third one. Let's find the fourth one. So fourth output is the input is 2. Then the output will be -3 times 2 plus 2. What we do is replace the variable x with what? The given input value. The given input value. So that is -6 plus 2 is -4. So when x equals 2, y is -4. Okay, we have one more. The last one is f of 4, or f of 4. So -3 times x is 4 plus 2. Then -12 plus 2 is -10. So that's the output for the input 4. X equals 4, y is -10. And then that's the set of all the order pairs. Set of order pairs, right? Therefore, this one. Make sense? All right. So when you find the range, you need an input. So input is given, and then replace all the x values with the input values. Then you get the output corresponding to the input value. Okay. Let's try problem P. Okay, problem 3 has a function f of x equals 4x minus 3, and the domain is given. 4 x values are given. There are 4 x values, right? So let's find the output for each input value. So -5. So these are the input values, right? input value x, right? These are all input value x. There are 4 of them. So based on this, let's find y. Okay, y is the output. So 4 times x. X is negative 5 minus 3. Negative 20 minus 3 is equal to negative 23. So when x equals negative 5, the y value, the output is negative 23. Okay, so and then how about f of negative 3? F of negative 3. So replace the input x with negative 3 minus 3. Negative 12 minus 3, negative 15. So when x equals negative 3, y is negative 15. Okay, f of negative 1. So input is negative 1. So 4 times negative 1 minus 3, then negative 4 minus 3, negative 7. So the third order pair is the input is negative 1, output is negative 7. Okay, the last one, f of 1. Okay, so 4 times 1 minus 3 equals 4 minus 3 is 1. So when x equals, the input is 1, then the output value is 1. So this is the order pair. Order pair for each input, 4 input values. Okay, example 4. Okay, we want to graph this function. Okay, graph a function means, okay, we know that x is input, right? X is the input. X is the input. And then f of x, this is y, right? Y, this is the output. Input and output. This is y, input value x, right? Okay, sometimes we call the input value. So y, actually y depends on, okay, look, the output. Okay, let me write it. The output y depends on input, right? So the output y depends on what? Depends on the input value x. Does it make sense? So the output value depends on the input. So we call this output. Is an output variable y is an dependent variable. So we call this, y depends on this. So this is a dependent variable. Okay, dependent variable. Dependent variable. Okay, because y is output, so y depends on x. So y is called dependent variable, and the input, input is, the opposite of dependent is what? Independent, right? Independent. So this is an independent variable. Independent variable. Make sense? So don't get confused. We have an input and output, and the input x is independent variable, and y is the output. So output depends on the input, so y is the output variable. Dependent variable. Okay, look at this again. X is input, right? Input. X is input. X is an input. Input, right? Input. It has in, and then so that we have an independent variable. X is input, so it is an independent variable. Can you see it? Independent. We have two spellings, in, right? In. So input, independent. And output, okay, y is an output variable. Output is a variable. The output depends on the input, so y is dependent variable. Dependent. So x is input, then y is the other one, the opposite, right? So dependent. Okay, so it's really important to understand, dependent variable and independent variable. Independent variables is what? Input values, right? Input. Okay, then let's graph this one. Okay, when we graph this, we need, okay, this is a linear equation, isn't it? So f of x is equal to 3/4 x plus 2. This is linear equation, right? Linear equation. Okay, linear equation means the graph is what? The graph is a straight line, right? It's a straight line. So we need, since this is a straight line, how many points do we need? We need 2 points, right? 2 points. Right, 2 points. So why don't we find 2 points and then plot those 2 points and then connect these 2 points to write to graph straight line? So why don't we use 2 points? So f of, in this case, the denominator is 4, right? Denominator is 4. So why don't we use a multiple of 4? X value, the input values. So independent variable x. So we will use 2 input values, that is multiple of 4, because we don't want to use fractions, right? Fractions. So let's use 2 points. That means we need 2 points, so 2 input values, right? 2 input values. Make sense? 2 input values. So in this case, we will use 4 and 8. All right. Let's use f of 4 and f of 8. Okay, so f of 4 is what? 3 over 4 times 4 plus 2. That is equal to, cancel out 4, then 3 plus 2 is 5. Okay, let's use let's use 0. I'm sorry, let's use 0 as well. Instead of 8, let's use 0. Because 0 is a very simple number. It will make everything 0, right? So use 0 for input. So 3/4 times 0 plus 2. Then that is 0 plus 2, which is 2. So the order pairs are this one. When x equals 4, y is 5. When x equals 0, y is 2. So we have 2 points. So why don't we plot these 2 points on a number line? On a xy coordinate plane. So here's 1, 2, 3, 4. 1, 2, 3, 4, 5, right? So when x equals 4, y is 5. So it's gotta go over here. So this is one. This is when x equals 4, y equals 5. Okay, 0, 2. When x equals 0, y is 2 over here, right? Okay, done. So we have 2 points, and then connect these 2 points, draw a straight line. So this is the graph of this function, right? This function. I explained, so this one takes long time. It looks like it takes a long time, but actually it is not. What we do is find the 2 points and connect. And what are those 2 points? X can be any input, any x values, but the best one is 0 and multiple of this denominator. And then you get the output value. So you have 2 points, x value, y value, x value, y value. You have 2 points, and then plot those 2 points, connect. That's it, right? Okay, let's try next one. Okay, problem 4, graph this function. Okay, when we graph this function, what do? We need 2 points, right? Okay, f of x means f of x is the y value output. So we will use one input and we will find the output that corresponds to the input. So we will find 2 points. So the best one is, the best x value is 0, right? 0. And what? Multiple of 2, multiple of the denominator. So let's find 2 y values based on x equals 0 and 2, the input values. So negative 1 over 2 times x equals 0, then 0 minus 3 is negative 3. Okay, if x equals 2, then plug in 2 for x, so now reduces negative 1 minus 3, so negative 4. So we have two points, right? 2 points. What are these 2 points? So when so here it is, when x equals negative 3. Okay, so let me write it here. So this means when x equals 0, when x equals 0, y is negative 3. Okay, for the second line, when x equals, the input is 2, then y is negative 4. So we have 2 points. So based on these 2 points, graph it. Plot these 2 points and then connect. The vertical axis is y. Okay, x equals 0. When x equals 0, y is negative 3. Here's 1 point. When x equals 1, 2, then y is negative 4. So negative 4. It's gotta be over here, right? So the graph will be this. Does it make sense? Okay, so it's really simple. When you graph a function or equation, since this is a linear equation, we need 2 points. 2 points. How to find 2 points? Use any two x values. The best one is x equals 0, and the other one is multiple of the denominator, of the coefficient. Actually, slope, right? Slope. The slope is fraction, so that x will be a multiple of 2. A multiple of 2. All right. Okay, example 5. Okay, we have an equation v is equal to 150t plus 2500. Okay, this means v is the output. Depending on the input value t, v is the output. So this means the value of the interest, the value of the investment, the value of the investment of 2500, this is not right, investment of 2,500 at a simple interest rate of 6%. So you deposit 2,500. Then every year you will get an interest, right? So the total value will change. So as time passes, you have your investment amount will be increased by the interest amount, right? So t is the number of years after you invested some amount. In this case, the amount is $2,500. So first of all, write the equation in function notation. What's the function notation? The function notation we use, f of x, right? F of x. So why don't we use the function name f and then x instead of x? This is the input. T is the input, isn't it? This is the input. So the input variable, independent variable is t. So why don't we use f of t instead of x? F of t. So that f of t is what? Write down the expression on the right side. It's noisy. Let me stop this. Okay, so the function notation is f of t equals 150t plus 2500. That's it. And then b is graph the equation for the values of t between 0 and 10. So the input values, right? T is the input values. So we can draw a diagram like this. Okay, I'm going to draw starting from 0. This is t, right? T is time in year, right? In year. Okay, so in year, right? In year. And then y value, okay, this is the v value. V is the value in dollars, right? In dollars value. Starting from 0. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like this. 10, 1, 2, 3, 4, 5, and so on. So from this, we need y value, the output, right? Output. So let's try to find output. When x equals 0, is this a straight line? This is a straight line, isn't it? Linear. This is a linear, right? Linear equation. Linear equation, right? Linear equation. So the graph is straight line. Straight line, right? Straight line. So we need 2 points. 2 points is enough. So let's use 0 to find the first point. So f of 0 is what? 150 times 0 plus 2,500. So that is 2,500. Okay, so here it is 1,000. Let's say this is 1,000. Here it is 2,000. This 3,000. 4,000. Okay, so 2,500 is here. So it starts with this point. And then let's use f of 10. F of 10, let's use f of 10. 150. Doesn't matter. In any value between 0 and 10. We want to find 2 points. Right, so plus 2,500. Then this is 1,500 plus 2,500. That is equal to 4,000. Right? So when x, the first point is when x equals 0, y is 2,500. For the second point, when x equals 10, t is 10, right? T is 10, y is 4,000. Make sense? Okay, so next point is when t equals 10, okay, t equals 10, let's go a little up. This is 4,000. So it should be this point, right? So this point is when x equals 10, y is 4,000. And this one is when x equals 0, y is 2,500, right? And then connect these 2 points. Looks like this. All right, so we graph the equation. Okay, letter C is, okay, the point 5, x equals, t is 5, then y is 3,250. So this should be on the graph. When x equals 5, then this point. Okay, this point should be when x equals 5, t equals 5, y should be 3,250. Is it true? Okay, let's check whether it's true. So f of 5, let's find out f of 5. Okay, f of 5 is what? 150 times the input value t, which is 5, plus 2,500. Then this is 7,500 plus, 750, right? 750 plus 2,500. Then this is equal to 3,250. Yes, this is correct. So this means when t is 5, y is 3,250. This is correct. So this point is on the line, right? This is correct. So then what do you mean this order pair? What does this order pair mean? Explain the meaning of the point. This means, 5 years after you invest 2,500, the value of that investment amount will be 3,250. Okay, so after, the value. So this means, okay, let me write it down. Okay, the meaning 5 and then 3,250 means the order pair means the value of $2,000, $2,500 after will be, okay, the value of 2,500 will be $3,250 5 years, okay, in 5 years, right? This will be okay, the value of the initial value, the initial amount, 2,500 will be $3,250 in 5 years. After investing $2,500. Make sense? So 5 years after you invest it, then that amount will become 3,250. All right. Okay, the last one is the problem number 5. Okay, a car is traveling in certain miles per hour. Okay, let's say it is 40 miles per hour. Okay, 40 miles per hour. Then we can write a distance is equal to 40t. 40t. Okay, 40t. 40 is the speed of a car. So d represent the distance in miles a car traveled in t hours. So t is the number of hours. So using this equation, okay, we will rewrite this equation in function notation. So function notation, the output is the distance. Output is the distance. So we can use f of something, right? F of input. The input is what? Hours or hours, t. In this case, let's use the variable t. So that is equal to 40t. Make sense? So t is the input variable, independent variable, and then f of t is the output. So that's the function, the function notation. So function notation is, f of something, f of input variable, or g of, you can use g of t or h of t, or you can use d of t as well. Doesn't matter. Anything is fine. You can use any alphabet for the function name. Okay, so we have a function f of t is 40t. Then let's graph when the input is from 0 to 5. So we need to find, this is the equation. This equation is a linear, right? Linear. Okay, this is a linear equation. Linear equation. Linear equation means what? Straight line, right? Straight line. Straight line. So we need how many points? We need 2 points. Right, 2 points. So let's use 0 for the input. Then f of 0 is 40 times 0 is 0. So we have an order pair when x equals 0, t equals 0, then y is also 0. Okay, now next one is f of 5. Let's use 5. So 40 times 5 is 200. So on the other order pair is when x equals 5, y is 200. Okay, not least about this one. Okay, so let's graph this one. So we don't have negative numbers, So we will start from positive 0 to the positive number. Okay, so t. Okay, t is the number of hours, hours. This is in hours. And then we will use d. Okay, d is okay, right? D, which is in miles, right? Miles. All right, so starting from 0, 1, 2, 3, 4, 5 hours. 5, 1. Okay. All right, so f of 0, then y is 0. Okay, and then t is 5. So at t is 5, then the d value, the distance is 200. So this is, let's use 100, 200. No, let's use 50. Okay, 50. Starting from 50, so 50, 100, 150, 200, and so on. So when t equals 5, y is 200. Over here. So t is 5, d is 200, this is 0, then it's 0. So connect these two like this, right? So that's the graph of this equation, this function. And then let's explain the order pair 3 and 20. That means if the input value is 3, then let's find out the output. So 40 times 3, that is equal to 120. Sorry, the question is 120. Sorry, 120. So yeah, this is correct. So when t is 3, so 3 hours later, then the total distance the car traveled will be 120 miles. Does it make sense? Right? So 320 means when t is 3, then this will be 120. Sorry for the noisy. This is when t is 3. 3 hours later, the total distance the car traveled is 120. That's what it means. Okay, so therefore, 3 and 120 means the distance, the total distance, I would say the total distance, the total distance the car traveled is 120. Okay, so 320, this order pair means the total distance the car traveled in 3 hours is 120 miles. Okay, we are done. Okay, sorry for the noisy.